Hello friends, welcome to my YouTube channel. In this video we're going to solve this problem from Grifit's quantum mechanics book. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new content for you and help me to grow my channel. If you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. Okay, so now you see, so here is the question. We have wave function for free particle, initial wave function, and here this capital A and small a are constant. Okay, real positive constant. Okay, so here we need to normalize this function, and also we need to find this psi of x comma t. Okay, and then also we need to find a probability density. Then we need to sketch the graph of this psi square. So then we need to find this expectation value of x, p, and x square, p square. Okay, so let's start. So here you see, this is our given function. This can be written this way or this way as well. So at t is equal to time t. Okay, so to solve this problem we must know few things. First one is psi of x comma 0 is equal to 1 by root over 2 pi minus infinity to plus infinity phi of k e to the power minus I kx dk. Okay, we must know this formula. Okay, let me write here properly, just give me a second. E to the power minus I kx dk. Okay, if you don't know, then first note this formula. Then phi of k is equal to 1 by root 2 1 by root over 2 pi minus to plus infinity, integration from minus infinity to plus infinity, psi naught or psi of x comma 0 e to the power minus I kx dx. Okay, and psi of x comma t, psi of x comma t is equal to 1 by root over 2 pi integration from minus infinity to plus infinity. Okay, let me write it properly. Minus infinity to plus infinity, phi of k e to the power I within bracket kx minus h cut k square by twice m t dk. So we must know this formula. Okay, then you can solve this problem. Just let me write here kx minus h cut k square into t by twice m. Okay, so hope you know this formula. If you don't know, then please note the formula first. Okay, so we must know all these three. Okay, very important formula. And also you should know this result, 0 to infinity e to the power minus t square dt, or you can write x square dx is equal to root pi by 2. So you have got this result in I think gamma beta function, error function, when you have studied in mathematical physics, gamma beta function and error function. Okay, you must have used this formula, right? So I have given a link of a video to understand this, how to get this result. So please watch that video first. Okay, so but here we are not going to show how to obtain this. We don't need to show, actually we're going to use this result, just remember. So remember this important integral result, we have to use this result. Okay, we don't need to show, we don't need to integrate this to evaluate this here, we don't need to show that, but we will use this result considering it is known to us. Okay, so hope you have understood this. Now you see, if you know this result, from here you can also obtain that minus infinity to plus infinity e to the power minus x square dx is equal to root pi. How? Let me show you. So it can be split into two terms, from minus infinity to 0 e to the power minus x dx. So it is infinity to plus infinity, minus infinity to plus infinity. So minus infinity to 0, then 0 to infinity, we can split like that. Okay, then again 0 to plus infinity e to the power minus x square dx, we can write this way. So here you see, so if you take minus sign common, if you take minus sign here, sorry not common, if you take minus sign here, then this lower limit will be upper limit here, in this case minus infinity, and here you're gonna get 0. Now you see, if 0 to plus infinity is pi by 2, then 0 to minus infinity is gonna be minus pi by 2, right? Hope you understood this. So that's why here you see minus, instead of this we can write minus root over pi by 2, and plus this is equal to pi by 2, root over pi by 2, and that gives, so here minus minus plus pi by 2 plus pi by 2, root over pi by 2 plus root over pi by 2, that means pi by 2. So we're gonna remember this result also, we need to use this result as well, we have to use this result as well. Okay, so here this result is very important, these two results are very important, we're going to use here directly. Okay, remember this, first note this three formula and write these two results as well. Okay, so then you will be able to solve this. Okay, so now let me clean this page. Okay, just give me a second. So now here you see, first what we are going to do here in this problem. Okay, first let us normalize. First question is normalize this psi x comma 0. So how to normalize this? So according to the normalization condition, minus infinity to plus infinity, mod of this square of mod of psi x dx is equal to 1. This is the normalization condition, right? So here you see, here we don't have any imaginary term here, right? So that's why square of this mod of square of this will be equal to mod of a square, then e to the power minus 2ax square. That's it, right? Hope you have understood this. Okay, now you see, so we can write this on this way, integration from minus infinity to plus infinity, mod of a square of mod of a, then e to the power minus 2ax square dx is equal to 1. That's what we're gonna have, right? So now here you see, let us put that u is equal to root over 2 alpha, sorry here not alpha, x, 2a x, square root of 2a then into x, so that we get u square is equal to 2ax square. So we are going to replace this by u square, right? Hope you have understood this. And if you differentiate this with respect to x, then what you're going to have, du dx, that's going to be root over twice a. So that's why dx will be replaced by du by root over twice a, right? So that's why this result can be written this way. That's why you can write this minus infinity to plus infinity, mod of a square is taken outside. It is constant, so it can be taken outside the integral e to the power minus u square du divided by root over 2a, which can be written outside the integral as well. Just give me a second. So it can be written this way, right? So now you see on the right hand side we have 1, so which means here, as I have already told you, value of this is equal to, as I have already told you, I have given this, that integration from minus infinity to plus infinity e to the power minus x square dx is equal to root pi, as I have already shown you. So we're going to use this result here. Okay, we can replace this by this result. Hope you have understood this, right? So now we have got mod a square by root over twice a, root pi is equal to 1, and which implies mod a square of mod a and root over 2a by pi. That's what we have got. Okay, and taking the square root, we're gonna have a is equal to 2a by pi. Here we're gonna have 1 by 4, because here we have a square root and on this side is square, so on taking again the square root we're gonna have 1 by 4, right? So this is the value of a we have got. Therefore this x naught of x psi naught of x or psi of x comma 0 is equal to value of a we have got 2a by pi whole to the power 1 by 4, then e to the power minus ax square. So here we have put the value of capital A that we have obtained here. So this is what we have got, right? So hope you have understood this. So this is the answer to this first question. Okay, normalize this. Now you see, to determine this phi of x comma t, so we have to use the formula that I have already given you. Okay, first let me go to the next slide. Okay, let me copy the given function. We're going to need this function. Okay, first copy this function as well, x comma 0, psi of x comma 0. Let me copy this and let me paste here. So we are going to solve question number 2 of this question. So here we must know this relation that you see psi of x comma t, this is psi of x comma 0, right? And psi of x comma t is equal to 1 by root over 2 pi minus infinity to plus infinity phi of k e to the power I kx minus h cut k square by twice m into t dk. So hope you have already noted this formula, right? And how to obtain this phi of k? That's nothing but, you know, phi of k is equal to integration 1 by root over 2 pi integration from minus infinity to plus infinity psi of x comma 0 e to the power minus I kx dx. That's how we can obtain, right? So now you see, now let us use this here, let us use this here. Okay, then what we're gonna have, then psi of k is equal to 1 by 2 pi integration of minus infinity to plus infinity 2a by pi whole to the power 1 by 4, not 2, e to the power minus ax, then e to the power minus ikx dx, and product of these two can be written this way: e to the power minus ax minus ikx. There was a square, ax, e to the power ax square. So I forgot to get this square, okay, minus kx. That's how we can write. Okay, hope you have understood this. Now if we take the minus sign common, this sign will be positive, right? Okay, so here we're gonna get positive if we take this minus common. Okay, that's what we're gonna have. First, here you see, okay, we can take this outside the integral, right? We can write like this way. Just give me a second. You see, you can write this here. Okay, you can write this way. Hope you have understood this. Now let me separate this. So how to evaluate this integral? Okay. First let me do one thing. What is the integral? First let me write the integral separately. Minus infinity to plus infinity e to the power minus ax square plus ikx dx. Let us take a is equal to, suppose a here, and b is equal to ik. Let me consider that way. Let me write that way. Then this integration from minus infinity to plus infinity. So let me give here equation number 1. Okay, first let me evaluate this integral. Okay, ignore this part first let me write the integral only. So e to the power minus ax square bx dx, that's what we're gonna have. Okay, now you see ax square plus bx. If you complete the square, then what you can do, ax here root over a x whole square, you can write this way. Okay, if you square this again, you will get ax, right? Then plus twice a b form, twice a is here root over a x, then b is here, you can write b by 2 root a, because here you see, if you cancel these two, then only you will get this term bx, right? Hope you have understood this. That's how we have arranged these terms. Then plus, this is now a square plus twice ab plus b square. You can consider this term as b. Okay, a square plus twice a is root over this, and this is b. Then it will be in the a plus b whole square form, that is a square plus twice ab plus b square. Okay, b root 2 root over a square. Then here you see, this term is not present here on the left hand side, so again we can subtract b by 2 root a whole square, right? Now here you see, this is a square plus 2a into b plus this is b square. Okay, so here we can write a plus b whole square, that means root over a x plus b by 2 root a whole square, and this squaring this, we're gonna have b square minus 4a. Okay, now let me consider this term as y. Okay, so then what we can write, ax square plus bx is equal to y square minus b square by 4a, considering, or you can say that we have considered this term as y, right? Hope you have understood this. Now you see, okay, now here you see, if you take root over a common from both the term, then here you're gonna have a, right? Because when you will multiply root a here, then root a cancels a to give root a, then you will get this term, right? Hope you have understood this. Okay, so we can write y is equal to this way. So now if we differentiate both sides with respect to x, so then what we're gonna have, root over a, and this is not function of x, this is constant, so that's going to be 0. Then on the right hand side, derivative of y with respect to x, so we can write that dx is equal to dy by root a. That's what we can write. Hope you have understood this. So that's why you see this integral can be written in this form. Okay, let me copy these things. First let me write this integral. Okay, here is the integral, right? And what we have got that we have got this result. Let me copy this one as well. So here we have got this, then we have got dx is equal to this one. Let me copy this. This is dx equal to this dx. So let me copy this one as well. Okay, now you see, so originally this integral was this, right? Let me copy this one, that's one as well. So this was the integral, here you see. Okay, so which can be written in this form, and now this can be written in this form as well, how I have already shown you, right? So this will be minus infinity to plus infinity. Here we don't need to change the limit, because when x tends to infinity, then y also tends to infinity. So that's why e to the power minus, here you see this term can be replaced by this, that is y square minus 4 b square by 4a. Okay, that's what we can do, and this dx will be replaced by dy by a. Okay, dy by root a, not only a. Okay, so now remember this, we're going to use this one again later. Okay, so remember this result as well. This is also a very important result for this problem. Okay, remember this result as well. Okay, so now you see, so what was the motive behind all this? To evaluate this thing, right? So therefore this integral what we have got, this can be written this way, minus infinity to plus infinity e to the power minus y square minus b square by 4a dy by root over a, right? Because here we have considered this one as b. Now if we put these values here, then what we're gonna have, so you can take root over a outside the integral, so this can be written this way, 1 by root a. Okay, so here you see this can be written this way, 1 by root a integration from minus infinity to plus infinity e to the power minus y square e to the power minus y square into e to the power minus b square by 4a, as we have already minus here, so that's going to be plus. Okay, so that's how we can write. Then here dy. Now here you see a is equal to a but b is equal to ik, so we can replace this b square by ik square, and squaring this, what you're going to have, minus k square, because I square is minus 1. That's what we're going to have, right? Hope you have understood this. Okay, now you see here in this part we have no variable, so it can be taken outside the integral. Okay, so now if we take this term outside the integral, just let me write this way. We can modify this like this way. Then here you see it can be written this way. We can write this here. Okay, outside the integral, right? Hope you have understood this. So again you see this result is nothing but pi, as I have already told you that whenever you see integration of integration minus infinity to plus infinity e to the power minus x square dx, that will be equal to root over pi. We're going to use this result. So here let me write here. Okay, just give me a second. Let me copy this and let me take a new slide. So here you see, so we can replace this by pi. Okay, so this is equal to e to the power minus k square by 4a divided by root over a, and here we're gonna have pi. So that is what we have got. Now this is the value of this integral. Now what we need actually, so now you see from this equation we need actually alpha of k, and let me copy this equation number 1. Let me copy this equation number 1. Okay, so here you see, so we need this alpha of k. So from 1 if we use this value here, okay, we have got this integral. This is the same integral here, you see, right? Hope you have understood this. Now let us use this value here. Let me use the value of the integral here. So that is nothing but this. Let me copy this result. So this is the value of the integral we have used here. Okay, so hope you have understood this. Now you see, okay, here you can see this root pi. Here root pi will be cancelled. Here we're gonna have only this, let me tell you, okay, 1 by root 2a, this root a is written here, and this root pi and root pi gone. Okay, so again twice a by pi whole to the power 1 by 4. Okay, and sorry, yes, okay, that's fine. Then e to the power minus k square by 4a, that's what we have got. So this is 5k, right? So now you see what is our motive. Our motive is to find x psi of x comma t, which is nothing but 1 by root over 2 pi integration, that formula I have already given you, minus infinity to plus infinity, phi of k e to the power I kx minus h cut k square by twice m t. So this is the formula to, let me write that to here properly. this is the formula to obtain psi of x comma t, right? Now let me use this result, that psi of k, which is equal to this. Let me use this result here. Okay, so now let me copy these two steps and let me go to a new slide. Okay, so here you see, so now you see, just give me a second. Okay. So now let me use this result here. Just let me use this result here, this one, and this part here. So this is what we have got. Okay, so now you see, it can be written this way, that this can be written this way as well. So e to the power ikx, e to the power ikx into e to the power this, right? We can write that way. So hope you have understood this, right? Now here let me simplify. Here you can see these two parts constant, so it can be written outside. Okay, so let me write the integral here. Okay, we can write this way. Hope you have understood this. Now you see, okay, now just give me a second. Instead of writing this, okay, we can let me write this one this way. Instead of writing this, you can write this way. What was that? Okay, let me write this way simply. Just remove this plus kx using the laws of indexes. We can write this way. Okay, now we have written this. Okay, so we have I have insert this value here, then you know, e to the power this multiplied by e to the power this, then you're gonna get this result, right? Hope you have understood this. So now you see, from here we can take this k square common, this k square also common, right? So we can write this way, 1 by, so let me copy this instead of writing all these things again and again. So we can write this way, and integration from minus infinity to plus infinity, then e to the power, so minus is taken common, then k square 1 by 4a plus h cut k square by twice m into t. K square is taken common, so it should be taken outside here. As minus is taken common, so this minus becomes plus, right? Hope you have understood this. So now you see, let me write this properly. Okay, then we have ikx. As minus is taken common, this minus gonna be this plus gonna be minus. Okay, so we can write k of minus ix, and here we have dk. Now you see, you can compare this again. You can consider this one as a. Okay, let me consider this one as a, and this part is as b. So actually I'm trying to get the form, this form here, you see this form, I'm trying to get this form. Okay, so again we're going to use this result. Okay, so here you see, just give me a second. Okay, so now let me copy this last step and let me go to a new slide so that I can explain these things. So let me copy this and let me go to a new slide. Sorry. So here is the new slide, and this is the last step. So what I'm trying to get, I'm trying to obtain this step. Let me copy this step. Just give me a second. So let me copy this. Okay, so I am trying to obtain this form. So here you see, let me consider this one as A and this part as B. Okay, hope you have understood this. Suppose here A is equal to this. Okay, this is equal to, suppose, A. This is equal to A. Okay, right. And B is equal to minus I x. This is equal to B, right? So you have understood this. Sorry, not K, this is only this, I have taken this. So if you consider that way, then this can be replaced by A. Okay, this can be replaced by A only. Okay, and here you see this can be replaced by B, and this is dk, right? Hope you have understood this. So now here you see, okay, now here you see this is in this form, right? This is in this form, so we can write this form in this way. So that's why this also can be written in this way. Here you see, instead of x square we have k square here, and instead of x we have k here. That is the only different things. As we had dx here we have dk. That's it, right? So that's why what we can do, we can write this integral. Let me copy this integral. Just give me a second. This integral we can write this way. Just give me 1 second. This can be written this way: minus infinity to plus infinity e to the power minus y square minus 4b square, b square by 4a. That's what we can do, and dy by root over a. That's what we can do, right? So here as soon as you write this step, okay, just mention this within bracket, right? So hope you have understood this. Now let me evaluate this. How to evaluate that? Again, let me copy this results, and let me take a new slide. Just give me a second. So here you see. Now let us replace this value of a and b. If we replace those value of a and b, then what we're gonna have? Minus infinity to plus infinity e to the power minus y square minus b square means this. So b square gonna be equal to minus I x whole square. That's when minus square is plus, then I square is again minus 1, x square is x square. So we're gonna have minus x square by 4a, and value of a is this. So let's put that value here. If you put this value of a here, then what you're gonna have? 4a. If you multiply 4 here, then what we're gonna have? Then we're gonna have, because we have here 4a, so if you multiply 4 here and here, then what you're gonna have? 1 by a plus h cut 2t by twice m. That's what you're gonna have, right? And here we're gonna have, sorry, just give me a second. Dy by root over a, okay, right? So value of a is nothing but this. Okay, just give me a second, let me go back to the previous slide. So value of a here, I think I have missed something. Yes, okay, here you see this I should be multiplied here and here also, so I have missed one I here. There should be an I. Okay, here we should have an I. Okay, in that case, so here also we're gonna have I. Okay, so let me check where I have forgot to put I. Okay, so then here also we're gonna have I. Okay, here you see we will have I here. Okay, so sorry for this mistake. And okay, now what to do, here you see, right, root over here we had a, instead of a we're gonna put this value of a. So here you see this is a, right, this is a. Let me use this value of a. Sorry, let me write this t here. Okay, so this is the value of a, that's what we have got. Okay, now this part can be written outside the integral. So this integration, so here you see what we have done here, we have put the value of b minus ix here and value of a here. So here we have 4a, so if you multiply 4 here and here on both sides, so this 4 will be cancelled by this 4 and will be cancelled by this 2, then you will get this one here, right? And instead of b square we have got this, right? Hope you have understood this. So if we get that, then you see, just give me 1 second. Okay, now we have got this. How we have got this? Here you can see this part is written outside. Okay, so now we have got this integral, right? So this part where you see which is under root, this part is constant, so it is written outside the integral. So we have got this result. So we have got the integral which we needed. So now our motive is to obtain this psi of x comma 2. Here we have already obtained this integral, so let me copy this. Now here you see we need to obtain this, and we have got this integral. Here you see we have got this result. Let me copy this integral. So now this integral, so now let me replace this integral by this result. Okay, then what you're gonna have, then this is the integral, right? Okay, let me replace this by this result. Then what we're gonna have, that psi of x comma t is equal to, let me write this part. Okay, this part is here, and then here you see that this part is replaced by this result. Okay, hope you have understood this. Now let me copy this and let me take a new slide again. So this is the result that we have obtained. Now here you see, if you multiply this two, then what you're gonna have, 2 root by root a, right? Okay, root 2 it becomes 2. And now you see, if we multiply 2 root a with this, then what we're gonna have, then we're gonna have 2 root a under square root, it will be square here, square of this 4a plus 2 root a square I h cut t by twice m. That's what we're gonna have. And on squaring it will be 4a, here this one is gonna be equal to 4a. So here 4a cancels. and here 2 cancels 4 gives 2, and so this will be 1 plus I 2h cut t by m, and one more thing, s would be there, 2h cut a t. That's what we're gonna have. So let this term be gamma. Okay, let us consider this term be gamma. So hope you have understood this, right? So what we have done, we have multiplied these two. After multiplying these two, we have got 2 root pi a, and this, from this we have multiplied 2 root a with this term, right? Hope you have understood this. So now let me cut these things. So here you see, and this part here you can see, if you multiply a here and here, this a cancel, here we're gonna have a, right? So that means here you see, let me copy this. So this is the term, so this was the term. So if we multiply a with the numerator and denominator both, then what we're gonna have, we're gonna have minus x square a by a cancel 1 plus I 2h cut a t by m. That's what we have got, right? So if you consider this part is gamma, then gamma square will be equal to 1 plus I 2h cut a t by m. That's what we're gonna have. So this part, this denominator can be replaced by gamma square, and this can be replaced by gamma, right? And so we can write this step like this. Just give me a second. So we can write this psi of x comma t is equal to 1 by root pi, because 2 root a is already multiplied with this, right? And twice a, 1 by 4, here we have pi, and 1 by gamma e to the power integration minus infinity to plus infinity e to the power minus y square minus x square a divided by gamma square. That's what we're gonna have, dy, right? So okay, here, right, putting gamma is equal to this, right? Hope you have understood this. Okay, let me write this one here. Now you see, this part can be written this way, this minus, it will be plus, right? So we can write this, let's make it plus, okay? And now there you see, from here what we can do, 1 by root pi and 2a by pi, 1 by 4, 1 by gamma. So here integration from minus infinity to plus infinity e to the power minus y. On removing the bracket, again we're going to have here minus e to the power, it can be written as minus e to the power x square a by gamma square dy, right? So this part can be taken outside of the integral, as this is constant, right? So let me write this one outside the integral. So that's how we can write here, you see. Okay, hope you have understood this. Just give me a second, let me rearrange these things. Okay, so this is what we're gonna have. So this is the result we're gonna have, right? So now again, as I have already told you that in this result of this integral, this is equal to again root pi, right? So that's why what we're gonna get, therefore psi of x comma t will be equal to 1 by root pi 2a by pi whole to the power 1 by 4, 1 by gamma then e to the power, let me write this one here, just give me a second, e to the power minus x square a by gamma square. Then instead of this integral we're gonna put root pi, right? So here root pi cancels, so therefore psi of x comma t, this implies psi of x comma t is equal to 2a by pi whole to the power 1 by 4 whole to the power 1 by 4 1 by gamma e to the power minus x square a by gamma square. That's what we're gonna have, right? So hope you have understood this. Now let me copy this result and let me go to another slide. Okay, so this is the result we have got. Okay, so this is what we need to find. Okay, so we have got this is the result of question number 2, right? Now we need to find probability density number 3. So if you see the question number 3, here you see this is question number 3. See, find, so psi x comma t mod of this, square of mod of this means this is probability density. This is probability density, right? Let me obtain that. So here you see. Okay, so how to find that probability density? Probability density is equal to square of mod of psi of x comma t. Okay, so that is equal to, mod square of mod of psi means that is psi into psi star. Psi star is complex conjugate of psi, right? So here we can write psi and psi star. Okay, so now you see here in this case, what was gamma? Gamma is equal to this. So let me copy the value of gamma. This is gamma. So here you see this part is not complex, this part is not complex. Here only the gamma is complex because you can see the imaginary number here, right? So complex conjugate of gamma, that's gonna be equal to root over 1 minus I 2a cut a t by m. That's what we're gonna have, right? So if this is psi, then psi star gonna be equal to, let me write here, therefore psi star will be equal to 2a by pi whole to the power half, sorry not half, whole to the power 4 1 by 4 e to the power minus x square. Here we're gonna write gamma star to represent the complex conjugate of gamma, sorry 1 by gamma star. Gamma star is the complex conjugate of gamma. Then e to the power minus x square a by gamma star square. Okay, so let me write this way, just give me a second, square of gamma star, right? Hope you have understood this. So if we multiply this one and this one, then what we're gonna have here, just copy, let me copy this, just give me a second. So then this probability density, this will be equal to, if you multiply this to this one and this one, then this power will be 1 by 2, in that case twice a by pi 1 by 4 plus 1 by 4, that's going to be 1 by 2, right? 1 by 2, and multiply this 2, then you're going to have e to the power minus, let me write it, minus x square a by gamma square, then minus x square a by square of gamma star, right? So you can take this common, x square a can be taken common, then within bracket we're going to left with 1 minus gamma square 1 by gamma square plus this negative sign will be positive now on taking minus sign common, then gamma star square, right? Hope you have understood this. When you multiply these two, then the power should be added, right? So here is minus, there is also minus, so minus is taken common here, right? Hope you have understood this. And here this 1 by gamma and 1 by gamma star, 1 by gamma and 1 by gamma star, right? Now if you multiply these two, then what you're gonna have? So gamma and gamma star, that's gonna be equal to root over. So here you see this is a plus b into a minus b, that means a square minus b square. A square here, a is 1 square minus b square, that is minus I 2 a square a t by m whole square. And squaring this, what we're gonna have? So as I square is minus 1, so it's gonna be plus 4 a square a square t square by m square. That's what we're gonna have, right? Hope you have understood this. So now you see we're gonna replace this part by this result, okay? Then what we're gonna have, let me copy this, just give me a second. Let me copy all this and let me go to a new slide. So here is the result, here you see. So now you see, let me replace this by this result, okay? Then what we're gonna have, let me replace this by this result. Here is, sorry, just give me a second, let me write this way, 1 by 2, okay? So this is what we have got. Now what will be this value? So 1 by gamma square plus 1 by gamma star square, so that's gonna be 1 by the square of this is 1 plus I 2 a square a t by m, and then plus, and square of this is gonna be equal to nothing but, just give me a second, sorry. So 1 by 1 plus, sorry, instead of plus here we have minus I 2 a square a t by m. That's what we're gonna have, right? So now let me cut this time. So if you take LCM and simplify, then what we're gonna have? So a plus b into a minus b, LCM is 1 minus, so I 2 a square a t by m, square of this and square of this. Then here 1 minus I 2 a square a t by m plus I 2 a square a t by m. So this one cancels this one, here we have positive, here we have negative, right? So hope you have understood this. This two cancels, right? So we're gonna have 2 1 plus 1 2 by 1 minus, so squaring this minus I square gonna be minus 1, so minus minus plus 4 a square a square t square by m square. That's what we have got, right? So we can replace this by this result, okay? So if we replace that, then what we're gonna have, let me write this result here, okay? So hope you have understood this, right? So that's what we have got, okay? So now let me cut all these things and let me simplify this. So here, okay, now in the question if you see there is a given term, okay, so this is replaced by w here. So now you see, let me tell you something. So this is the required result we have, okay, this is the required result we have, but so So this term is very big, so that's why, to make it simple, so that's why another symbol W is used here. So let me tell you how it is used. And yeah, wait, give me a second. Now let me do one thing. What we can do here, I think there should be 1 by this. Let me go back to the previous slide. So here you see, so this is gamma into gamma star. Here we have here you see 1 by gamma and 1 by gamma star. So that's why if we put this one here, then 1 by this should be written. Okay, so hope you have understood this. So now you see, if we simplify this term, if you take m LCM here, 2a by pi, here let me write the a here. Okay, this is square root of this and square root of a, and 1 by here m square plus 4 a cut a square t square by m square. Okay, square root of this, and so it can be written this way. So instead of writing m square here, we can write the m square here directly. Okay, so that's what we can do. Then e to the power minus, okay, x square a to m square. If we multiply both the numerator and denominator by m square, then what we're gonna have, m square plus 4 a square t square. That's what we're gonna have, right? So hope you have understood this. So now you see what we can do here. Okay, let's do one thing. Just instead of taking LCM, let me write this one this way. Just give me a second. Okay, let me modify another way. So here square root of this 1 plus, we can write this term this way, 2 cut a t by m whole square. We can write this way, right? Okay, so now here you see, let me cut this. Okay, so here you can write this root a this way. You can multiply this one here, root a. So here we, under the same root, we can write these things. Okay, hope you have understood this. So now you see here, okay, this term can be written this way. Okay, 2 by a 2 into a plus 2 a cut a t by m whole square. We can write this way. Okay, and then this can be written this way as well. Let me show you, just give me a second. So let me write the 2 here. Here you see, let me rearrange these things. Okay, here you see that here we have root, so we can write this. Let me write here root, and let me write again square. Okay, for simplicity, square. So now let us consider this term w as given in the question. Though it is not given in the question, you can use that. Okay, root over, it is given in the question now, but if not given, then also you can that symbol. Okay, or you can choose any other symbol, p, q, whatever you want. Okay, to make this equation simple. Okay, so let me write here w e to the power minus 2 x square omega square. Okay, omega square, right? So here this omega, this is w, I think. Okay, and this is written as this is nothing but a by 1 plus 2a squared a t by m, this is square here. Okay, so this is the probability density. This is the probability density, right? Now the next question here, what is the next question? So we need to draw the graph. Okay, then so in order to draw that graph, let me write this result on the other side. Let me take a new slide. Okay, now you see. Now if you find the limit, here you see limit w t tends to 0 as t tends to 0. So what was the term w? Let me copy that. Limit t tends to 0, w is nothing but this is w, right? So now you see, as t tends to 0, this term gonna be 0, so here we're gonna have root over a, right? And if you find limit w t tends to infinity, then what we're gonna have here, if you put t is equal to infinity here, this term here you see this denominator will be infinity. Okay, so if that is infinity, if the denominator becomes infinity, then so this quantity will be 0. Anything divided by infinity is 0, right? So here we're gonna have 0. Now you see, as time goes on from 0 to infinity, this value w decreases, right? This value decreases. If w decreases, then this value will be also decreased. Then what kind of graph we're gonna have? Let me draw this. So for t is equal to 0, if we are getting this graph, that is more square of psi, square of mod of psi. Okay, then this is at t is equal to 0. Okay, and for t greater than 0, as t increases, this density decreases, then graph will be something like this. Okay, as time goes from 0 to infinity, when time goes from 0 to infinity, then value of omega decreases, so this also will be decreased, so it will be lower. And as we know that this, according to this normalization condition, minus infinity to plus infinity, this must be equal to 1. So that's why to satisfy this condition, this must be broadened. Okay, right? Hope you have understood this. For t greater than 0, right? So what we can write, that therefore the wave packet of free particle broadens spatially with time. Okay, so hope you have understood this. So this video is already too long, so I'm gonna answer these two, the remaining two questions. Here you see this remaining D and E in the next part of the video. Okay, thank you for watching. See you in the next video. Bye bye.